So this is a quick video that kind of follow up on the area under the curve, velocity curve, just talking about Reimann sums in general. So there are really three types of Reimann sums that we're going to get to know right away in this class, and that's the right-hand Reimann sum, the left-hand Reimann sum, and the midpoint Reimann sum. So, and they're all determined by how you figure out the height of the rectangle. So in this first example, you can tell if I'm going to do a right-hand sum, that means I'm going to determine the height of the rectangle by the right side of the interval. So, so we would draw a triangle like this, and a triangle like that, and a triangle like that. So those would be the three triangles that I use. I'd find the area of each one of those triangles, add them together, and that would give me an approximation for the area under the curve. So remember, I'm trying to approximate just this area, so there's a little bit of overlap there. I mean, a little bit of excess there that I don't want, but that's the nature of trying to approximate. That we don't have a nice way to find, we don't have a formula for this type of shape. It looks almost like a trapezoid, but it's curvy, so it's not a trapezoid. So one way to get at it is just breaking the piece into sort of rectangles. Okay, if we're using left-hand sum, then that means we're going to determine the height of the rectangle by the left side. So it looks something like this. So we're going to use these rectangles to find the area under the curve. So we find the area of each rectangle, add them up, and that would give us an approximation for the area under the curve. And then the third example, oops, that doesn't look the same, does it? I'm going to lower this one. So in this case, I'm going to use the midpoint of the interval to determine the height. So I would draw a line up like this, and where it hits the fx line, that would be the height of my rectangle. So that would be the height of that rectangle, and if I go up there, whoops, that would be the height of that rectangle. So you can see with each type of Reimann sum, the height of the rectangle is different. Now, however, you also notice, because each of them are divided into three subintervals, that the width of each rectangle in all three cases is the same, right? So if we're going from 0 to 3, and we're taking three rectangles, that means the width of each one is 1. So remember, the way we find the area now is just add up the rectangles. Now, I'm not going to guess at these values, but we know that they're some functional value based on f. So all I have to do is plug in the right x to get the right f, to get the right height. So this is going to be 1, because that's the width, times the first height in this case would be f of 1. And the second height, whoops, would be right there. That's going to be f of 2. And the third height would be right there. And notice that's f of 3. So if we multiply 1 times f of 1, that would give me the area of this rectangle. 1 times f of 2, that would give me the area of this rectangle. And 1 times f of 3, that would give me the area of that rectangle. Okay, same thing with left-hand sum. We have a width of 1, so that's going to be 1 on the outside. But this time, I'm going to take f of 0 to get the height of the first rectangle, and f of 1 to get the height of the second rectangle, and f of 2 to get the height of the third rectangle, because I'm plugging in 0, 1, and 2 to get this height, that height, and that height. And then finally down here, again, the width is 1, so I'm multiplying width on the outside. On the inside, I'm going to have, in this case, I'm plugging in that x value, which would be halfway between 0 and 1. So it's going to be f of 1/2 plus f of 1.5 plus f of 2.5. So that's the left hand, right hand, or right hand, left hand, and midpoint Reimann sums. Now, what if we had the same type of drawing, but it wasn't from 0 to 1, it was from A to B. So we want to make this generic now. So the right hand sum and let's still use 3 subintervals. But the problem is, I don't know where A and B is. A could be 0 and B could be 72, or A could be 0 and B could be 4 or 2.5 or whatever. So the question is, in this case, what is the width of each rectangle? Well, clearly we're going to take the endpoints. So just like up here, we found out that the width of each rectangle, well, we found that just looking at it, but if we could also find out by going 3 minus 0 divided by 3, because the total distance, and there's 3 subintervals, so we're taking the total distance and dividing by 3. So we could do the same thing down here. We could do, so the width in this case is going to be B minus A divided by 3, because I'm dividing into 3 subintervals. And if I'm doing the right-hand sum, notice this is where it gets tricky. I'm going to do B minus A over 3 on the outside. On the inside, I'm still going to take f of something. Well, what am I going to take f of? I'm going to take f of A plus B minus A over 3, because I want to go one width over. And then I would take f of A plus 2 times B minus A over 3, and finally f of B, because I would use B for my last height. And you notice if we're doing a left-hand sum, it would be similar, B minus A over 3, and that would be f of A plus f of A plus B minus A over 3 plus f of A plus 2 widths. And that would be my left-hand sum. And of course this gets even more complicated when I'm trying to do the midpoint sum. But one more thing, what if instead of 3 subintervals, what if we would have done a whole bunch of subintervals? Like maybe n subintervals. Well, notice all that does is changes this to an n, changes that to an n, and it changes that to an n, and it really doesn't change anything else, does it? Of course, there'll be more of these in here now, so I'd have to put a little plus dot dot dot, but the last one would still be f of b, right? Because I'm still going to plug in that last side. And again, there'd be more of these in here, plus dot dot dot. I don't know what the last one would be. Well, we do know what the last one would be, don't we? It would be f of b minus A over n. So I didn't finish converting all those. That's an n, that's an n, and that's an n. So that's about as generic as we're going to get on this video. But hopefully this clears up the difference between the right, left, and midpoint sums and gives you a start on this idea of just thinking formulaically, what does the Reimann sum look like? And if we know a formula for this top line up here, we're basically using it to find the heights of the rectangles by plugging in the right x values.